Good afternoon and welcome to our next module in the Developing Distance Learning module focused on good agricultural practices and IPM with a focus on fall armyworm mitigation. Today we have Mark Edwards, our consulting entomologist at Villa, and he's going to discuss Module 6 with you, which is using pesticides for fall armyworm control. Over to you, Mark.
Thank you, Nyaleen. Up until now, with all of these modules that are focusing on fall armyworm control, we've discussed a number of different topics, and what we'd like to do today is talk about the actual pesticide use and how to do it correctly. Because fall armyworm is a recent invasion in Africa, most farmers in Africa are not used to the pest. And in the past, they were not really used to using much pesticides on maize. But with this new pest becoming such a problem, it's probably going to be more and more common that farmers will be using pesticides for the fall armyworm control. We've already discussed the safety and health aspects in some of the modules for using pesticides. And what we want to do today is make sure that while people are taking care of their safety and the personal protective equipment and so on, we also want to make sure that the actual application of the pesticide is done correctly. This is important for all sorts of reasons, some of them being environmental reasons. We don't want people contaminating the environment with incorrect application. It's of course also about the safety issues, and then it's also about being effective in terms of the actual control, because if one doesn't apply the product correctly, and one must remember that these things cost money and for farmers in Africa are often quite expensive, then one wastes one's time and money using the pesticide. So as already mentioned, we've detailed in previous modules that farmers may need to apply pesticides for fall armyworm control, and once again we should emphasize that we want to base this on scouting results. We don't want farmers to apply pesticides willy-nilly. We want them to actually have reasons for applying pesticides. It's critical to make sure that any pesticide is correctly applied for the reasons I've already given. So Module 1 addressed the responsible use aspects of insecticide applications, and in this particular module we will cover spraying with a knapsack sprayer. In Africa, most of the farmers will have access to a knapsack sprayer, and that will be the equipment that they will be using to apply pesticides to control fall armyworm. We want to make sure that this spray equipment, the knapsack, is used correctly and is well maintained. And then a very important issue is to make sure that the knapsack sprayer is calibrated so that the right dosage is applied. If calibration is not done, the incorrect dosage can be applied, and one can sit with all sorts of issues such as inadequate control. Over-application can lead to phytotoxicity on the maize plant, and one can also contaminate the environment due to over-application. The knapsack sprayer should be calibrated at least once a season, and this should preferably be at the beginning of the season so that the farmer knows that he's going to be spraying correctly through the rest of the season. Ideally, of course, one can also say that the knapsack sprayer should be calibrated during the season, but in reality, most people will only calibrate once a season and at the beginning of the season. So in the module materials we've presented or will present on the website, there will be various presentations and documents about calibration that you can consult when doing training with farmers. And I will briefly go through some of the aspects of calibration then in this presentation. So what we will be watching now is a video animation of how to calibrate a knapsack sprayer.
Mary, when last have you calibrated the sprayer?
Calibrated? I just filled it up and started spraying. What does calibrating even mean?
Sprayer calibration means calculating and clearly understanding the amount of spray liquid you should apply to a certain size area. You need to do this at least once every season.
That sounds a bit difficult. Do I really have to do it?
It's very important that you do it, Mary. If you don't, you stand the risk of failing to properly control a pest infestation. Calibration is also really easy. I'll show you. So we have to do this here because this is where application will take place. You will also need to do the calibration because you'll be spraying later. I'll do the timing and note-taking.
Okay, I'm ready.
Before we get started, have you inspected your sprayer?
Yes, everything is working properly and there are no leaks.
Perfect. Fill the sprayer with water. There's no need for us to use pesticide for calibration. Now measure a 10-meter strip in the field and mark it with a pole where it starts and where it ends. I'll use this piece of paper to take notes and this stopwatch to record time. We'll also need a bucket and a measuring jug.
I have them right here.
Good. First, we need to note the swath width. The swath width on this sprayer is 50 centimeters. Bear in mind that different nozzles will give different swath widths. Do you know how big your sprayer's tank is?
It holds 15 liters.
Good. We'll have to calculate the flow rate. This is where the bucket comes in. You'll have to spray next to the bucket first. Make sure you pressurize the spray as you normally would when spraying the fields. Spray into the bucket now and I'll start the 30-second timing immediately. When 30 seconds is up, you must move the nozzle away from the bucket. 27, 28, 29, 30. Great. Right on time.
So what now?
You can carefully pour the water in this bucket into the measuring jug and I'll record the volume. This spray, measure and record process has to be done 4 times. We'll have to repeat this 3 more times so we have 4 readings and we can work out an average. Let's take a look at the notes we have so far. We know that our swath width is 50 centimeters and the spray tank volume is 15 liters. For the first 30-second spray, we measured a volume of 330 milliliters, 320 milliliters for the second, 335 milliliters for the third, and 315 milliliters for the fourth. If we add this together, we get a total volume of 1,300 milliliters. Next, we have to work out the average volume. How we do this is we divide the total by the number of times we measured. So 1,300 divided by 4 gives us an average of 325 milliliters. Now that we have the average, we can measure the flow rate. Flow rate is the volume of liquid that passes through the nozzle per unit time. To measure the flow rate in milliliters per second, we'll divide the average, which is 325 milliliters, by 30 seconds. This gives us a flow rate of 10.83 milliliters per second. To get a flow rate in liters per minute, we multiply the flow rate in milliliters per second by 0.06. This gives us 0.65 liters per minute.
Remember the 10-meter strip we marked with the poles at the beginning? What was that for?
We'll be using that now for the third step. This is where you come in again, Mary. You have to start spraying before the pole marking the start of the 10 meters we measured. Make sure that you walk at a normal speed. I'll start timing once you pass the starting pole and stop once you reach the end. That took you 8 seconds. We have to repeat this 3 more times. Okay, let's have a look at the notes again. The first time we recorded was 8 seconds, then 9 seconds on the second measurement, 11 seconds on the third, and 11 seconds again on the fourth. That gives us a total of 39 seconds. Now we have to record the average time it took to spray 10 meters. Again, we divide the total time by the number of times we measured. That's 39 seconds divided by 4, which gives us 9.75 seconds. To get the speed in meters per second, we divide 10 meters by the average time. So 10 meters divided by 9.75 seconds gives us a speed of 1.03 meters per second. For getting the speed in kilometers per hour, we divide the speed in meters per second by 3.6, which gives us 3.69 kilometers per hour. For step 4, we'll have to calculate the volume sprayed per hectare. To get that, we'll use this formula.
So that'll be 60,000 multiplied by 0.65 over 3.69 multiplied by 50. That should give us 211.25 liters per hectare.
That's right. Well done, Mary. This label of edition 150 SC shows us the application rates, dosage, and other information. As you can see here, the dosage rate is 200 to 250 milliliters of product applied to 1 hectare. It also says the product must be applied in 200 to 400 liters of water per hectare.
So how do I calculate how much pesticide I need to add to my knapsack?
It's simple. You just use this formula.
That'll be 15 over 211.25 times 250 divided by 1, which gives us 17.75 milliliters per tank. So I will need to add 18 milliliters to my spray tank.
Correct again. You see, I told you this was easy.
I'm really getting the hang of this. So from the calculations, we can see that we will spray enough water per hectare. That's 211 liters per hectare, which is slightly above the range of 200 to 400 liters of water per hectare given on the label. But what if the label said we should apply 400 liters of water per hectare?
There are a few ways to apply a greater volume of water per hectare. You could either walk slower. If you walked at half the speed, you'd be applying 422 liters per hectare. Or you can use the same type of nozzle from the same manufacturer. There will be nozzles that will deliver twice the volume.
Perfect. Let's get to work then.
As one can see from this short video animation, calculating the dosage and the spray volume to apply to maize is perhaps not as easy as people think. And unless we are able to teach farmers how to do this, or whether we calculate this ourselves as trainers and then give the information to farmers, it is vitally important that one has this information and that the correct dosage is applied. We have presentations on sprayer calibration that you can download from the website, and they will give more detail on sprayer calibration that you can have a look at. One of the ways in which to do this the easiest as a trainer is to run a group exercise with the people that are being trained. And what you would need for this is, of course, a knapsack sprayer. You would need water to spray. You would need poles with little flags on, of course, to put at the end of the 10-meter strip. Preferably a measuring tape to measure out the 10 meters. Like it was shown in the animation video, you would need a bucket and a measuring jug or measuring cylinder, and you would need somewhere to record this information. One would also need something to time the spraying and the walking with. This can be done with an ordinary watch with a second-hand dial, or one can use many cell phones, of course, have little timers on them as well, so one can use that too. And then one should let the group of trainers or trainees calibrate the sprayer. If you have very large groups that are not, that are maybe not suitable, one could divide it into a number of different groups. But this would, of course, mean you would have to have all this things like the knapsack sprayer, etc., available for each group. Here you can see the equipment that might be necessary for a calibration exercise. We've got 2 poles there with little flags on that we can use to measure off the 10 meters. On the floor at the bottom next to the flags, you'll see a tape measure to measure off the 10 meters. There's a watch lying there that can be used to time. There's also a smartphone that has a timer on it. Of course, we also have to have the knapsack sprayer there, and you can see a bucket and a measuring cylinder. With this simple equipment, one can then run a group exercise to calibrate the knapsack sprayer so that the farmer is applying the right dosage of pesticide onto the maize. We have tried to help trainers as much as possible in terms of calculating these various formulas and so on. So there is an Excel spreadsheet as well that one can use and enter the information into. If you have a tablet or even a smartphone with an Excel app on it in the field, all one does is there are places in the Excel spreadsheet where one enters the various measurements in, and the spreadsheet will calculate everything for you. So we're trying to make it as easy as possible to actually calibrate a knapsack sprayer in the field. These two photographs, of course, illustrate a typical knapsack sprayer, and one of the exercises you can do with trainees is use these photographs to ask them if they know what the various components of a sprayer are. So one can, for example, ask them what number 1, 2, 3, 4, and 5 are. And by interacting with the audience in this way, people often learn about these things much better than when one actually just shows it to them. You would have noticed in the video animation that the trainer was asking Mary whether she checked her sprayer and when all the connections and so on were correct. These must all be tightened so that they don't leak, because again, leaking leads to possible overexposure of the spray person as well as contamination of the environment. The next 3 short videos show what can happen if the knapsack is not maintained properly. So if we run this short video, so on this short video you can see where the pump action is and the hose comes out of the pump to spray the thing. The connection is not is loose, and there is spray material leaking out of the connection. This is a particularly dangerous situation because this will immediately wet the back of the sprayman because he's wearing it on his back, of course, the knapsack sprayer, and then you will definitely be overexposed to the pesticide. In this short video, you can see there is a loose connection at the nozzle end of the lance, and the sprayman is busy spraying, and it is spraying backwards onto his foot while applying the pesticide. This short video shows the trigger assembly on the spray lance of a knapsack sprayer, and you can see because of a loose connection it is also leaking at the trigger assembly. Once again, this leads to potential overexposure and contamination of the environment. In previous modules, we have touched on the subject of fall armyworm that moves into the whorl of the maize plant and how difficult it is to control the fall armyworm there. Therefore, we're also going to briefly discuss the use of various adjuvants to facilitate control of fall armyworm that might be in the whorl of the plant. What you can see in this slide is somebody opening up the whorl of a maize plant to indicate how deep in the whorl the fall armyworm is actually situated. As you can imagine, it's very difficult to get a spray solution so deep into the whorl by simply spraying over the top of the maize plant. What we're trying for you as trainers, I think one should discuss with the trainees whether any of them have any knowledge of surfactants or whether they've ever used them. The other issue that one would have in certain areas in Africa is, will there even be adjuvants available? But the addition of adjuvants to any spray solution can definitely enhance the control of a pest like fall armyworm. This slide is basically going to show us what a surfactant does when added to a pesticide solution for spraying on a leaf surface, like a maize plant. Often the droplet that is sprayed will often bounce off the leaf surface and will be lost and will not control the pest that is being sprayed. Some agrochemicals have wetting agents that are added to them, and this wetting agent enables the droplet to stick to the surface of the plant. But what we're going to discuss here is a surfactant that actually spreads the droplet on the plant surface so that it easily can penetrate the whorl when spraying over the top of the maize plant. This slide shows us two droplets on the right-hand side that have been sprayed, and as you can see, they are sticking to the plant surface but are not spreading, whereas on the left-hand side, the addition of a spreading agent has enabled the droplet to spread over a larger area of the leaf, thus enhancing the control of any pest that might be feeding on that leaf. These different products also act in different ways, and you can see that not all of them are as effective as others. Right on the right-hand side, we have two water droplets. We have two different spreading agent products, and you can see one is spreading much more than the other. And on the left-hand side, there's very little spreading that has taken place. So the action of surfactants is to make sure that the product spreads over the leaf surface and enhances your control of the pest that you're applying the pesticide for. This short video will show you a pesticide that has been applied to maize plants to try and control fall armyworm, and no surfactant has been added to the pesticide solution. What you can see on the maize plants is discrete droplets of the applied pesticide. In this case, what we have done is we've added a blue dye to the spray solution to enable us to see where the droplets are going. If you apply a pesticide in this way over the top of a maize plant, with the idea of controlling fall armyworm in the whorl, you are not going to get very good control. In the next slide, we will see an application of the same pesticide, again with a blue dye added, but where one can see how almost like magic, the spray solution spreads all over the leaf of the maize plant and penetrates into the whorl, where it has a much better chance of actually controlling the fall armyworm. So there is the application with the blue dye, and as you can see, there are no discrete droplets formed on the maize plant's leaf. What happens is that the insecticide solution immediately spreads on the plant and will also spread down into the whorl. Here we've taken one of these maize plants and we have opened up the leaves of the whorl to show you how far the blue dye has penetrated down into the whorl and down the leaf sheath of the maize plant. This type of penetration into the whorl will help to control fall armyworm that has entered the whorl of the maize plant already. Thank you very much. We've covered briefly some of the topics that are addressed in Module 6 to make sure that farmers apply the pesticide correctly